Given an infinite series, I would like to have in our back pockets techniques for determining whether or not that series converges or diverges. So here's a list of what is coming up next. My first test I'm going to refer to as test for divergence. I think I mentioned that last time. The integral test, the comparison test, the limit comparison test, the alternating series test, the ratio test, and the root test. We're also going to discuss the difference between absolute convergence and conditional convergence. So let's come back to the test for divergence. I proved that last time. I don't recall what examples I had, so I made up some new ones. Take a peek at this series. The test for divergence says the following. If the nth term does not go to 0, as n increases that bound, the series for free does not converge, and I justified that. And so let's even take a peek at the limit. As n increases with that bound of the nth term. Now, just by observation, would you agree this denominator right here, as n increases that bound, is going to go to this? Well, I meant that. That being the case, I do think this limit divides to 2, which is not equal to 0. Now, please listen to my choice of words carefully. This is not enough. I need to see more of this. I need to see, number 1, that you use some test. Number 2, you showed the word needed for that test. Number 3, identified what test you used. And number 4, tell me whether the series converges or diverges. So it may sound nitpicky on my part, but this is what I'm absolutely demanding. So, by the test for divergence, since that limit is not equal to 0, I'll start abbreviating that soon. I think likewise. Whoops, I've got some blockage. Now you take a peek at this series. Certainly it is true that that series, that limit does not exist. After all, as n increases that bound, this nth term is popping back and forth between 1 and -1. And so the limit does not approach any single fixed real number. Therefore, I know I'm not stating things exactly the way I did before, but I'm putting in all the right ingredients. And I think likewise. Now watch my change. So I think what I'm going to change in my answer is absolutely nothing. It may be the case that this mathematical beast does not pop back and forth between 1 and -1. But it is the case that as n increases that bound, this expression right here is jumping all over the place in between numbers that are at extremes 1 and -1. So this expression right here does not approach any one fixed finite real number as n increases that bound. Therefore, this limit does not exist. Therefore, our series in question diverges by the test for divergence.